Okay, imagine we have 6 students standing in front of this mirror, but the mirror doesn't go the entire length of the students. The mirror starts and stops just as shown in this picture. And there's a couple of versions of this question. One is, what can each student see in this mirror? What are the limits of their line of sight when they're looking in the mirror? In other words, what reflections can they see? And the other question is, who can see who? So you've got Al, Bo, Cy, Di, Ed, Fred. You got all these students down at the bottom, and you're trying to figure out if the person labeled DI can see ED. Can Di see Ed? Now that should be obvious. They're both staring in the mirror. They should be able to see each other. The question comes a little bit more murky when you look at these students on the outside of the mirror. Like, what can they exactly see? Well, let's do this a couple of different ways, because both methods will actually answer the same question. If I want to figure out who sees who, it's all about reflections. And we know that in a flat planar mirror, all the images are exactly opposite the person, equal distance on the other side. So the images of each person, I'm just going to eyeball them, would be like this. There's the image of Cy. And then right above would be the image of Di. And the idea is that that distance and that distance are the same. Right above Ed is Ed. Right above Fred. And I've got a couple more down here. Now, the idea is we're trying to figure out if Al can see Bo in the mirror. Can Al actually see where Bo's image should be? Now, don't get caught in the fact, okay, well, the mirror ends here. Bo doesn't even have an image. People over here might be actually able to see Bo. His image will exist in that mirror, because don't forget the light's going to travel from Fred, for example, bounce off the mirror and hit Bo, which means the light's also going to travel in the other direction, bounce off the mirror and hit Fred. So Fred will likely be able to see Bo. But the easiest way to do it is to just line up your image. So we've already got our pink images all drawn there. Now if I simply go back, and notice I've got some vectors already pre-made over here, or some arrows already made. If I start, for example, at Al, and let's just put Al's light ray there. What can Al see? Can he see himself in the mirror? Well, obviously, if I send a ray of light up to his image, it doesn't even hit the mirror. So there's no possible way that reflection, Al can't see himself, and that should make sense. He's way off to the left of the mirror. Similarly, if I slide that ray of light over to Bo, it doesn't even hit the mirror, so Bo's image is not going to be seen by Al. But when I keep sliding it, even Cy does not hit the mirror. Di does not. However, Ed looks like it might. See how it just barely glances there, right at the edge? So it is possible that when he's looking at Ed, Ed's light, remember, travels from Ed, bounces off the mirror, and the angle of incidence has to equal the same as the angle of reflection, like that, so that those two angles are the same. And then this reflected ray appears to line up with that image. So it looks like Al can see Ed. Now I'm going to move this little vector over. What about Fred? If I do it like that, whoops, I just want to move the tip of that, like that. There you go. Now, well, clearly that is hitting the mirror. So that means that light coming from Fred will bounce off the mirror like that and appear, as far as Al is concerned, to be traveling in this straight line, and he'll see the image of Fred in that mirror. So that's one way. You could do that with every single person to see who they see. And I'm not going to go through all the answers. It would be too much on the drawing. The other way to do it is to test the limits that each person sees. And to do that, I'm going to use Al as an example. Al can only see this first left edge of the mirror and everything else that hits the right edge of the mirror, and obviously everything in between. So if I do the limits, he can see a ray that starts from his eye and strikes the mirror, or even goes in reverse and strikes that edge of the mirror. Similarly, he can see any light coming from the far edge of the mirror. and obviously any other ray in between. Now we know these rays hit the mirror and bounce off, so that angle of incidence equals angle of reflection. So that first ray, for example, will bounce off so that this angle right there is exactly equal to that angle right there. Now I, again, have just eyeballed it, but you could easily take a protractor and do that. Similarly with the ray at the end. So if I grab that ray and bounce it off the mirror, at the far side, I can see the limits of images that Al can actually see. And again, I have eyeballed it here, but the idea is this far ray, that angle and that angle should be the same. So you can see that anything in this region is visible by Al in the mirror. So he can see Ed and he can see Fred. Now you could do that with all the other candidates. Bo, you could test his limits by sending a ray of light to this edge and a ray of light to that edge and seeing what is trapped by those reflected rays. Similarly with everybody else.